Alright, this is Adam Dierig with AdvancedDimensions.com, and I'm going to show you a quick way to take your 3D Disto files and get them prepared for a CNC machine. We've had a lot of customers kind of asking about this, and I've actually run a CNC machine before, so I have a little bit of experience processing DWG files to get them ready to cut. So what I'm going to do is I'm going to open up a file, basically just hitting the 3D Disto shortcut folder to the exports. This is the same laptop that I use when I go out in the field. We did a project in my drafting company that was basically templating out an area to do a countertop. We can see that. Let's see if I can get some good snapshots here. These are just some quick snapshots of what I was templating, what was going on here, minus the doorway, but you can see there's a piece of extruded aluminum here, and I was templating out where that extruded aluminum was because there's a countertop that was going to wrap a octagon, it was an octagon or a hexagon shaped room divider that was in the middle of a room. So that's kind of what we're looking at. And I'll open up the CAD file of what was exported. This laptop is only running AutoCAD 2012, but all the techniques that I'm doing today will work in pretty much any version of AutoCAD as long as it has these commands. But we actually use 2016 in the drafting company that I run, but it will work in anything, from 2004, I would say on. So that was this job. This is a typical export minus these two log files here. This was because I opened up a DXF file, but we're going to have a CSV file, one DXF file that just has the name, and then there's two other DXF files, one that has a 2D in the name and one that has a 3D in the name, and there's a text file as well. This, I'll just open up the text file just to give you an idea. What this is just like the XYZ coordinates. Not really useful unless you have a program that can kind of decipher it. And that's same with the CSV file. It kind of does the same thing. It's just in like an Excel format. So I do have a little bit of confusion when it comes to the DXF files. And I'm going to try and explain that now in a little bit more detail than I would normally in a demonstration video. I'm just going to get rid of those log files. So there's three DXF files. There's one that has without the 2D, or one without a 2D or a 3D, and then a 2D and a 3D, like I was saying before. What I'm going to do first is I'm going to open up the one that does not have a 2D or a 3D in the name, and I'm going to show you what it looks like and why you shouldn't use it. Again, this is AutoCAD 2012. I have this installed on my laptop because it just gives me a better idea when I'm out in the field. I can open up stuff and mess with it just to make sure it's nice. There's also a free version. It's called DWG TrueView that Autodesk makes. It's basically like a reader for DWG files. That is also very nice because you don't have to pay for it. So it's going to say it's read-only. This kind of happens with DXF files. If you click OK, it'll be read-only. If you click No, it kind of is already open in the background. But you can see what this does is it kind of like puts a border in the model space. I honestly can't tell you why Leica has it exporting. It's kind of one of my questions that I should ask them, but really, I would never use this file. It's just one of those things that is very confusing, and people are always calling, going, "What's going on?" It's like it's trying to set up a view for you, or it's trying to set up something that you can display or use in a presentation, but but it's pretty pointless other than that, and everything is actually scaled down to this 1/200 scale. So I would just say take that file and pass right over it when you're doing stuff. I'm just going to close AutoCAD and open up the other two files. So there's a 2D, and I'll show you what that looks like, and I'll show you what the 3D looks like, and then I'll show you how you're going to process through the information to get it ready to cut on a CNC machine. So in the 2D, what you see is basically like a plan view. And again, I was taking measurements of like a octagon shaped thing. I think there's 1, 2, 3, 4, 5, 6, 7, 8. Yeah, octagon shaped room divider in the middle of this huge room that we're putting a countertop basically on all the outside edges of the octagon. So we wanted to make sure that the angles between them and everything were fine. Something very handy with the 3D Disto, and you can see all these peripheral points around are what I use to relocate the Disto, because I had to relocate it 4 or 5 times to get it around this whole structure so that I could template it all. If I was on the inside, I would have been able to do it in one shot, but because it was the exterior of this octagon shape, I had to get it in multiple points. But anyways, so this is all 2D, and then by 2D, that means the Z has been taken out of these points. So if I were to orbit this by typing in orbit, you will see that everything is kind of in a flat surface in the Z. You know, everything's at the 0 origin point in the Z. What I'm going to do next is I'm going to open up the 3D version and show you what's going on there. So the 3D version at first looks identical to the two-dimensional version, but when I orbit it, you're going to see that these points are now have a Z value. With the first couple of shots, I took the reference points at zero, and then everything above that reference point is in the positive, and below that reference point is in the negative. So what you get when you do export it is you get a series of, and I'm going to actually look at this in the two-dimensional one. Just making sure this is all right. Here's the two-dimensional one, just orbiting it to make sure. So I'm going to just view it from the top. So this is basically like a normal two-dimensional AutoCAD file. You can see that there's these points here. What happens is every time you take a point with the 3D Disto, it's going to make this point icon, which is just a point style in AutoCAD, and then it's going to draw a line between the two if that's the way you have it set up. You can turn that on, you can turn that off with the 3D Disto software, but by default it's on. So it's really what I want is that line. If I was going to be cutting a countertop, I would want to turn off all the points. I want to isolate the line that's there and then combine those lines, because a CNC machine likes a closed polyline, or at least a polyline, to be able to assign a router to it in whatever software that you use. So what's nice about this program is, or the export is, it gives you everything in layers. So I'll show you in the 2D how I would combine these lines into a polyline, and then what I'll do is I'll show you in the 3D it is possible as well with AutoCAD. So I'm going to just turn off the point entities. So I'm going to turn off that guy. I'm going to turn off the IDs because I don't really need those right now. I'm going to turn off the disto points, and it looks like I've isolated the line that I want, or the lines that I want. And the biggest thing, and the thing that I'm going to do too, is I want to save the original. That's just something that I like to do. And we would obviously save this file as something else too. I'm just going to move it down a certain increment. Let's do it 800. So now I've just basically copied that down 800, and now I can turn back on these points. So if there was something of interest that I wanted to see with that, I could see it. But this down here is the line that I'm going to deal with. So because of this exercise, these were outlet plugs that were happening along the border. I don't really care about those right now because I'm working on the countertop. So I'm just going to get rid of those. So I'm just deleting them. This area here where there's a space, there was a door right here, but in this space, the Disto was set up here and there was a column in the way, so I wasn't able to get the scan in between those. But really this can just, I can just draw another line between these 2 points, and that would carry through the extrusion. So as you can see, if I highlight all this, there's 72 lines. They're just individual lines. I'm working this just like I would normally a normal AutoCAD file. There's nothing special going on. The first thing that I usually do is I check corners. So I want to make sure that this is an actual corner, and that one looks like it is. This one I know that there was some funky things. I'm not quite sure why. Maybe the level changed, but what I'm going to do, if I take a dimension here, you'll see the minuteness of this. You know, we're an 1/8 of an inch right now, so and I know that this is a good, you know, anywhere where there's a break in these lines is a point. If I were to go look at the one at the top that I copied this from, you would tell that that's where those points are. So I know that there's a couple points here that could be just, I might have mistaken them. So like this should go here and this should go here, kind of a thing. And if that doesn't look quite right, you can also do like a chamfer and kind of connect those. Every time I do this, I always just double check to see what the size is. So right now we're just a little over 1/16 of an inch there. And if I were to delete this line, it gives us a better corner. So I would go through this whole thing and make sure that those are all looking okay. You know, the other thing that we could do is we could just draw a line and draw a line and get rid of these two as well. I mean, this is probably exactly what's happening, so I don't, you know, want to get too crazy, but I think it's probably fine. So I'm just going to go finish this thought here. Now, the other thing too that I've done is I've drawn lines over top of this because obviously, you know, if you want to scribe it right to the wall, that's one thing, but this was something that's kind of visible from both sides. So anyways, I've kind of gone through and cleaned it up a little bit. And now I'm going to join it together and make that polyline so I can further edit it and get it ready for the CNC machine. So there's two different AutoCAD commands that you can use. There's a command called join, which is J-O-I-N, and I just entered that into the command prompt and hit enter. Now it says it wants basically select an object or select multiple objects. So right now you can see these are all individual lines, and I'm just going to grab everything and then right click, and you can see that the individual lines have been joined to a point. Now AutoCAD's funny, you kind of have to join it a couple of times and that might not work. Or it might work, but it kind of goes through and does everything that it can. Just repeat it as much as you need to, and then when this happens and you can't join them, it means they're not connected. So you can do one of two things. You can just connect them, or you can draw the line, and you can see that's a little bit over 1/8 of an inch, under 3/16 of an inch of a line that we just needed to connect. So again, join those again, and we have a continuous polyline. Now, these segment points are where the scan was happening. So if you were to take a scan at less increments, you know, every 12 inches or every 15 inches or 16 or whatever, those points would be less. But because I was scanning every, I think it was every 6 or so inches, I can measure, it's giving me those points. So actually those 18 inches. But But that now is a continuous polyline, and if I were to say offset that 24 inches, you know, I would obviously clean this up before I did that, but you get the gist of it. So that's one way to do it with the join command. I'm going to actually undo that a couple of times. And I'm going to show you another way if the join command does not work. Let's get this back to where it was before. Yep, so these are still now all individual lines. There's a command called pedit, which is P-E-D-I-T. And the pedit command is polyline edit. So I'm going to do the pedit command, and I'm going to do I think I screwed that one up. So again, I'm going to just type in pedit, P-edit, enter, M for multiple, because I want to select multiple lines. I'm going to select multiple objects. These objects I would like to convert to a polyline, so I'm going to just hit enter for yes. And I would like to join them. The nice thing about this command, so I'm going to hit J for join, is it has a join type. So if you remember that there was one area that had a space, this join type is, it'll kind of like fill the spaces. So I can go through and I can say, you know, if there's any spaces in this greater than 1/4 of an inch, or at 1/4 of an inch and less, join those up. So if I just type in 0.25, enter, it should have made the whole thing a polyline. Occasionally you do have to run this command again. Oh, that didn't do it. So let's try that again. P-edit. I'm going to zoom in here. I just figured this command out. P-edit multiple. I'm going to pick you and you. And I'll do join again, and then I'll do the join type as like, I don't know, 10 inches. There it goes. So that just closed that gap in between and has created a continuous polyline without me having to do it manually. So that's kind of a nice way to do it. And occasionally, for some odd reason, the join command won't work. The pedit command will usually always work. So what I do too is kind of like use X lines and kind of get for the offset here. And this is kind of my personal preference, but this is kind of how I would work this through to get it ready for a CNC machine, is do these X lines, and I'm just kind of picking 2 points along this and getting things close, and then taking these and like combining them together and then doing that offset of the 24 inches deep so that the outside edge of the countertop is clean and smooth, and then the inside edge could be scribed to the wall. That's kind of how I'd go through the CNC process of this. But for right now, we've just created a join polyline, which is what we need to start with, and then you can go from there to get your CNC programming done. So this is the 2-dimensional file, and I'm going to just close this without saving it because I don't want to save it. Let me show you how you would go about doing it with a 3D file, because there's a thing that happens, and this is another issue that I've seen, is if I want to do the same thing in this 3-dimensional file, so I'm going to turn off all these entities, and I'm going to copy this geometry down 800. And I can turn these back on. And I'm going to go, let's do the pedit command. We'll get rid of these guys while I'm here. Go away. Go away. And we'll do the pedit command. I'll save closing that gap. And I'm going to grab M for multiple. And we got everybody. And then we'll hit Y for yes, J for join, and join type we'll leave at 0 for right now. And it's going to say 0 segments added to polyline, and hit enter one more time, and it's going to not do anything. It has created a bunch of polylines, but it hasn't joined them. So now if I want to try, maybe let's try the join command and see what happens. Kind of joined a couple and joined a couple there, which is interesting to me. But But the biggest thing is orbit. What the problem is, and this is a big deal, I'm surprised it actually joined those. I wasn't thinking it was going to. But you can see here, see how the line is like wavy? And that's not something that we can really mess with on a CNC machine. That's not something we can mess with on a CNC machine because it's not coplanar. Anytime you're joining this stuff, you need to join it having it being flat. So if you're taking it from the 3D file, the first thing that you need to do is flatten everything. So flat, and I'm going to select just these objects. And I want to remove hidden lines, it doesn't really matter. And now if I orbit this, you'll see that waviness that we were just messing with is now gone. And now this is all at a 0. So if I do an ID point here and I pick a point on this line, you're going to see the Z is 0, and Z is 0, Z is 0, Z is 0. If I come back up to here and I do the ID points, look at my Z measurement. And even in this, you can see it's changing almost a ½ inch, you know, between the two different sides, because that's what the floor and or the geometry was doing. So now that we have this perfectly flat entity, even though that join command worked, I'm going to do the pedit command again. The pedit command didn't work because they weren't coplanar. And I'm going to join these with a join. Wait a minute. I think that's why it occur. Oh, it's a 3D polyline. Oh, that's why we didn't. That's why it joined. We don't like 3D polylines. We want a two-dimensional polyline. So I just exploded that to get it back to lines, and then I'll do the pedit command. And I'll do multiple, and I'll grab them, and I'll do yes, and I'll do join, and join type of 20. That actually closed this gap, I think. Closed a gap, and it closed this one. And it created my polyline. And again, I can go through this and work the CNC from it. So either way, from the 2D or from the 3D file, the 3D file you have to flatten it first. Like I suggested before, I would copy it down, flatten it, create polyline with the pedit command or the join command. If you use the join command well in the 3D mode, it's going to create a 3D polyline, which is not something that you can machine. At least with my old CNC machine, I couldn't mess with that. And then with the 2D file, you need to use the join command or the pedit command, and it will join those objects together, and you'll be able to assign a router to them so that you can properly cut this out. So that's taking the DXF file that the 3D Disto creates and using it and getting it to a point where you can use it in a CNC machine or whatever you need to use it for. That's how I would process it if I even wasn't doing a CNC machine and I was just doing a drawing. So thanks for tuning in. This is Adam with AdvancedDimensions.com. If you have any questions, please feel free to look us up and give us a call. Thanks for watching.